Okay, so similar type problem that we were working on in the last video. It's just that notice rather than being a complement, we're looking at supplement. Okay, so we know supplementary means that they add up to 180 degrees rather than 90 degrees like they do with complements. Okay, so we have an angle and its supplement. Okay, angle and we have its supplement. Okay, so it says an angle measures 8 more than 3 times its supplement. So we know something about the angle, we know nothing about the supplement. So let the supplement be x. Okay, and then the angle, 8 more than, so that'd be 8 plus 3 times, so obviously 3 times it, so we could write that as 3 times the supplement, which is x, plus 8. Okay, now we know that these two angles have to add up to 180 pesos. Okay, so we're going to get 3x plus 8 plus x equals 180. Okay, so collecting similar terms, I get 4x plus 8 equals 180. Subtract 8 from both sides, so I get 4x equals 172. And then I divide by 4. So let's see, 172 divided by 4. And I'm getting 43. Okay. All right, so we have to check to see whether or not that works. Okay, so, all right, let's see. My answer wants me to find both of them. Okay, so the angle that I'm talking about would be 3 times x plus 8, so I'm going to get 3 times 43 plus 8. And let's see what we get there. 3 times 43 plus 8. So that gives me 137 degrees. And then if I look at the supplement, well, the supplement is just x, so I get 43 degrees. Okay, so if we take a look at this, remember these two angle measures have to add up to 180, so if we look at 137 degrees and we add 43 degrees, we are going to get 180 degrees. Okay, so I should feel pretty good, okay, about my answer. Okay, we're good there. Okay, another one, you know, just like the last one, we just have different numbers, but again, notice we're working with supplements, so we know that they have to add up to 180 degrees. Okay, so I have some angle, and I have its supplement. Okay, so we know that the angle is 20 less than, that means minus 20, 3 times its supplement. So I know nothing about the supplement, so we'll let that be x. And then I know that the angle would be 20 less than 3 times that. Okay, so that would be 3x minus 20. Okay, and we know that these have to add up to 180 pesos. Okay, so we go 3x minus 20 plus the x. That has to give us 180 degrees. Collect similar terms on the left-hand side, so I get 4x minus 20 equals 180. Add 20 to both sides, so I get 4x equals 200. And then I divide by 4, so I get x equals 50. Okay, so let's take a look at what our answer would be and check our work. Okay, so we have this angle, and it's 3 times x, so that'd be 3 times 50 minus the 20. Okay, so that's going to be 150 minus 20, so I'm going to get 130 degrees. And then I look at the supplement, and we know the supplement is just x, so it has to be 50 degrees. Okay, so if this works out, they have to add up to 180 degrees. So if we take the two angle measures, 130 and 50 degrees, obviously they add up to 180 degrees. So I should feel pretty good about my answer on this one as well. And we're in good shape. Okay. All right, so let's see. We have another special type of pair of angles, okay? They're called vertical angles, and they come up on a regular basis, okay, in mathematics, okay? And when we're talking about verticals, notice it's a pair, okay? So we have a pair of angles, and they form a vertical pair. Okay, so let's see what's going on. Vertical pairs, okay? Well, it says they're non-adjacent, okay, so they can't butt up against each other. They can't have a shared side. They're non-adjacent, and they're formed when lines intersect. Okay, so I have this line and this line intersecting at a point, and we know they only intersect once, okay, and I have these four angles that are formed. And so if we pair things up as non-adjacent, okay, so if I start, like, let's say with angle 1 right here, well, it's adjacent with 2 because it shares a side. Angle 1 and angle 2 share a side right here, and their non-common sides form a pair of opposite rays. So 1 and 2 are definitely adjacent. And so if I look at 1 and 4, well, it's the same thing. 1 and 4 are adjacent because they share a side, okay, and a common vertex. Notice their non-common sides form a line. Okay, so I can't pair 1 up with 2 or 4, so I have to pair it up with 3. Okay, and notice that 1 and 3 are definitely non-adjacent. Okay, so one pair, okay, one vertical pair would be angle 1 paired up with angle 3. And then we're going to have another pair. If I take a look at, say, our 1 and 3 are already taken care of, so will 2 and 4 work? Okay, so if you look at angle 2, again, we know that it is adjacent to 1 and it's adjacent to 3. Okay, but this is a pair of non-adjacent angles, so I would have to link 2 up with 4. Okay, and obviously 2 and 4 are not adjacent, so another pair would be angle 2 and angle 4. Okay, and then we kind of take a look at that and, you know, well, is there something even more special about vertical angles? You know, would the measure of 1 and the measure of 3 be related, and would the measure of 2 and the measure of 4 be related? Okay, well, every year I ask that, and I always get somebody that comes up with, okay, vertical angles are congruent. They have the same measure, okay? Okay, so would we say that angle 1 and angle 3 have the same measure? And would we say that angle 2 and angle 4 have the same measure? Well, let's take a look at an example and see whether or not that works out. Okay, so I have two lines intersecting. They only intersect at one point. And so I have these four angles. Okay, and what if I know one of them? Okay, I know this guy right here is 48. Okay, so we take a look here and I say, let me sort of take a look at this 48-degree angle and sort of pair it up with angle 3 here and see what would be happening. Well, notice that they have a common side and a common vertex, and notice that their non-common sides are a pair of opposite rays. So we know that going all the way across would have to be 180 degrees. Okay, so the measure of angle 3 here we could find by going 180 degrees minus the 48 degrees. Okay, and so that would give us, what, 132, like this? Okay. And then notice I could do the same thing up here. If I take this 48-degree angle and sort of pair it up with angle 1 and say, okay, well, what's going on with these two guys? Notice again It has a common side and a common vertex, so they are definitely adjacent. And notice their non-common sides here and here form a pair of opposite rays, so going all the way across again would be 180 degrees. So once again here I would have to go 180 minus the 48, and so again I'm going to get 132 pesos. And look at angle 1 and angle 3 are a pair of vertical angles, and notice they have the same measure. And so notice if I pair up this 132 with angle 2, or this 132 with angle 2, notice that these two angles have non-common sides that are opposite rays, so that has to be 180 degrees. Same thing here, this has to be 180 degrees, so the measure of angle 2 would be 180 minus 132. So notice that when we do that, we're going to get 48 degrees. So how about that? It certainly looks like pairs of vertical angles will have the exact same measure. 132, 132, 1 and 3 are a vertical pair, and then 48 and 48 because this is the other vertical pair right there. And that's going to happen 100% of the time. That is actually called the vertical angle theorem, which we will prove in the near future. Okay, that'll wrap it up for videos this week.